We are absolutely delighted to have with us a team of 3 researchers, most distinguished researchers, who will be presenting to you an absolutely interesting paper on economic fitness and complexity using some super modern approaches to measuring the performance of economic systems. This work is absolutely new, involves a team of distinguished researchers, and will bring into focus interesting and novel ways of measuring economic performance compared to the existing methods. The team is unique, includes a group of people working in economics and physics and other quantitative areas in science. We're delighted that this team has been put together by our own our colleague Pasquale Scaramozzino, who is a professor of economics in the School of Finance and Management, a good man, and a distinguished researcher. And he has his degrees from the University di Roma La Sapienza and also from the London School of Economics, and has taught at a number of UK universities, Bristol, UCL, and also University di Roma Tor Vergata in Italy, which I was happy to visit and can attest their highest distinct role and credibility, and also has published in the top journals in economics, a long list to be cited here. But also, in addition to his academic distinction, he has served as a consultant to the World Bank and the Asian Development Bank. So we welcome you, Pasquale, but we also welcome your colleagues, Professor Luciano Pietronero, who is the president of Enrico Fermi Research Center in Roma. And he has been a full professor of condensed matter theory in physics at the University of Groningen and of condensed matter physics at the University of Roma La Sapienza. So struggling both his academic credentials, both in the Netherlands and Italy, and indeed worldwide. And he is a graduate of distinguished universities, University of Roma La Sapienza, and worked with the Xerox Webster Research Center in New York, and also the Brown Bovee Research Center in Baden. He's played a lot of distinguished roles with a long list, and of course also being a fellow of distinguished societies, including being a fellow of the Institute of the American Physical Society since 1990. Given his distinguished role and contributions in physics, which is using to influence developments in economies. And the third contributor is Dr. Andrea Zaccaria, who is a researcher at the Institute for Complex Systems and a consultant at the International Finance Corporation of the World Bank Group. So you have here a trio of 3 distinguished researchers who will be sharing their work with us. We are indeed delighted and honored to have you here. We will start, I think they want to do like a 3-man drama. So starting with the Pasquale. Pasquale, you have the floor.
Thank you very much, Victor, for your very kind and generous introduction. And as Victor mentioned, the 3 of us are planning to give each one of us a presentation. I will start first, and then Luciano Pietronero and Andrea Zaccaria will intervene and will talk about their specific contributions to this area of research. So let me first try and share my PowerPoint. Yes, can you see the screen?
Oh, yes, very clear, thank you.
Good. So the title of this talk is Economic Fitness and Complexity, a novel approach to the analysis of comparative economic systems. Now, the idea of this approach is to use recent methods which were originally developed in physics, in the physics of complex systems, to economics. And the main attraction of this approach is that it's much more detailed, much more granular, and in a way much more satisfactory than conventional approaches in economics, in comparative economic analysis, and in the analysis of economic growth. And is able to uncover some deep structural features of the economies which cannot be properly studied using traditional aggregate methods. So the presentation will be with Luciano Pietronero and Andrea Zaccaria, but this work is also the outcome of collaboration with a number of other researchers. I personally worked with Angelica Sbardella, Emanuele Pugliese, Giambattista Albora, and others. But Luciano Pietronero was really the leading figure in promoting this approach. Now, the big issue, what are the nature and causes of the wealth of nations? This is really the title of the very first book in economics by Adam Smith, in 1776, an inquiry into the nature and causes of the wealth of nations. And this is still, I believe, the key issue in economics. Why are some countries better off than others? And why do we observe countries that succeed, that experience sustained rates of growth over long periods of time, while others are stuck in a low income and low growth development path? This is not, in a way, the key issue in economics. Now, ultimately, differences across countries or regions are due to differences in productivity. What are the main determinants of differences in productivity across countries? This is a fundamental issue in economics. Now, in 2005, one of the leading contributors to the theory of economic growth, Elhanan Helpman, wrote a book, and the title of the book was The Mystery of Economic Growth. Still, after centuries of trying to work on these issues and an upsurge of contributions, especially since the 1950s, 60s, there are many aspects of economic growth that we simply, as economists, do not understand. And the mainstream analysis of economic growth can be categorized in two different strands of literature: exogenous growth and endogenous growth. So briefly, in the endogenous growth literature, this originated really with Robert Solow in the 1950s. And the growth is explained in terms of accumulation of physical capital. Technical progress is not explained in terms of the model, it's given exogenously. And the countries' growth, economies growth because they save, invest, and physical capital increases, and their production possibilities increase over time. Now, one key feature of exogenous growth models is that because of decreasing returns to physical capital, the rate of growth of the economy will slow down. So there will be a tapering of the rate of growth of the economy as they approach their steady state equilibrium path. And one important implication of the exogenous growth literature is that we should observe a catching up of low-income economies to higher-income ones. Low-income economies are further from their frontier, and there is more scope for growth, and so that should grow faster than higher-income countries that are already close to the technological frontier. So we should observe this catching up. Poorer regions grow faster than richer ones, and eventually, or asymptotically, they would tend to converge. Now, the endogenous growth literature, this originated more recently, mostly from the mid-80s, although there are some ideas were developed earlier. In the endogenous growth literature, different from the exogenous growth, there are constant returns to the factors that are being accumulated. And this means that there is no slowing down of the rate of growth over time. Now, these constant aggregate returns could be due to externalities. For instance, the learning by doing variety. Learning by doing was originally studied by Arrow, who noticed that, observed rather, that new technologies are incorporated in the economy, mostly in new investment. So it's through investment that new technologies get incorporated and get diffused into the economy. So strictly speaking, rather than learning by doing, we should talk about learning by investing to refer to Arrow's approach. So there are, in Arrow's view, there are decreasing returns at the firm level, but because of these externalities, due to the average level of investment and capital in the economy, there are constant returns with respect to aggregate capital. And this is able to overcome the limitation of exogenous growth models. Now we have endogenous technical progress, where economic decisions affect the rate of growth of the economy. And the main determinants of growth in this approach are seen as investment in research and development or human capital, but also more recently, an important channel growth has been identified in the openness to international trade. So there is some form of learning by exporting. Countries that export are able to grow faster. They incorporate more quickly technological progress in their production structure. And the predictions of endogenous growth are quite different from those from exogenous growth. There is no catching up. Countries that are richer may keep growing faster than countries that are poorer, and therefore we would observe a strong persistence of differentials in incomes and rate of growth across economies. So there are these sharply different predictions. We could also have multiple equilibria, which could be a feature of especially endogenous growth theories. We could have multiple dynamic steady states. This could be associated with increasing returns rather than constant returns. And with a multiplicity of equilibria, we could have that the long-run equilibrium of the economy, the equilibrium path, might depend on the initial conditions and the starting point of the economy. So we could have non-ergodic growth models. So because of increasing returns and non-convexities in technology, the initial condition may still have an effect in the very long run. And we could have poverty traps. So the economy could be stuck in a low activity, low growth equilibrium. And whereas there are other superior equilibria in the economy characterized by higher activity and higher rate of growth. And one way of moving the economy away from a poverty trap would be a discrete investment effort or industrialization effort, which could take the form of a big push. And the theory of the big push started already in the 50s with Hirschman and other authors, was formalized more recently by Schleifer, Summers, and Vishny in an influential paper in Journal of Political Economy that identified the conditions under which a big push, a discrete investment effort coordinated typically by the central government, may be necessary to shift the economy away from a low equilibrium path into a high equilibrium path. But all these traditional analyses tend to focus on aggregate macroeconomic variables, and even micro-funded approaches do not fully account for the diversities across firms, for the heterogeneity of firms, and for the complex nature of their complementarities and interactions. So there arises the need to adopt a more fine-grained and more structural analysis of the productive system of the economy and of its potential. And one way of rationalizing this and understanding the role of the role played by the complex system of interactions in the economy is to focus not on physical factors of production, typically capital and labor, but rather in the set of capabilities with which an economy is endowed. So looking at capabilities rather than physical factors of production enables us to have a more nuanced and a more structural view of the economy, which is able to account for the role of complexities. Now, capabilities can be defined as those skills that enable the economy to expand into new productions and facilitate the adoption of new technologies. Early contributors were Hirschman, who noticed that capability make it possible to create backward and forward linkages across economic sectors, thereby increasing the overall productivity of the system. And also our own Edith Penrose, who taught at SOAS, was the first professor of political economy at SOAS, who developed a highly influential resource-based theory of the firm. Later contribution by Thies and others, who noticed that capabilities are essential for a coherent, competence-based growth of the firm. Now, Abramovich shifted the focus from a firm-based notion of capability to a social one. So social capabilities can be defined as all those attributes that affect a country's ability to operate modern and large-scale business. And the contention in this analysis is that ultimately the main drivers of growth are the social capabilities with which an economy is endowed. I'd also like to refer to a contribution by Haskell and Westlake, Capitalism Without Capital. Haskell and Westlake try to understand the reason for the decline in the rate of productivity growth that has been experienced by most Western economies in the last few decades. And they identified the decline in the rate of productivity growth in the reduced investment in intangible assets. These are human, organizational, managerial capital, which includes reskilling of existing workers and the ability to attract new talent. And they show that investment in intangibles can be associated with increases in the total factor productivity of firms and sectors. So we have to go beyond the purely physical view of investment to consider the role of intangibles. Now, a particularly important analysis in this respect has been carried out by John Sutton in a number of papers and books. Together with Treffler, Sutton wrote an article in the Journal of Political Economy, which is quite a seminal work in this area. Capabilities are essential for firms to maximize the returns from their investment, but also for creating the conditions for further investment. So they're important in a dynamic sense. But an important and a critical issue of capabilities is that the capabilities required to produce high-quality products will always be scarce. So even in developed countries, even developed countries, there will be a whole range of variety of outputs that are produced. And even developed countries cannot just produce high-quality products because capabilities would be a constraint. From the point of view of the of growth theory, the implication of Sutton analysis is that capabilities will be concentrated in some countries or regions in order to take full advantage of agglomeration externalities. Now, agglomeration externalities play a key role in the modern economic geography. Now, why do cities exist? Why do we live in cities that are polluted and faced with congestion and commuting times rather than living in the countryside? Well, it's because if we live in a city, we enjoy the externalities from being close to talents. There are some externalities associated with concentrating talents and abilities and capacity in even geographically in geographic proximity. And similarly for abilities, for capabilities, this will end up being concentrated in countries or regions. This implies that the market structure of an industry also will tend to encompass a variety of products of different qualities, and that there will be a limited number of leaders of firms which hold a dominant position in each industry. Globally, capabilities are a scarce resource, and so we'll see that they tend to concentrate in some countries to take full advantage of agglomerations economy. And the comparative advantage of each country will then reflect their relative endowment of capabilities and the ability to to produce high quality products. And in this context, available capabilities become a key factor in global trade specialization and in determining the growth prospects of each country. But capabilities are unobservable. Okay, so we say some nice things about capabilities, but how do we measure them? And the key idea is that the underlying capabilities of an economy can be inferred from the complexity of its production structure. So if we find a way of measuring the complexity of the production structure of the economy, this can be a very accurate indicator of the underlying capabilities of an economy, and therefore also of its growth prospects. Now, important early contribution was by Hausmann, Huang, and Roderick, who realized that it is possible to make inferences on the unobservable capabilities of the economy from its export specialization profile by looking at the revealed comparative advantage of countries. Hidalgo and Hausmann developed their product space to measure the degree of complexity of each economy. And the product space by Hidalgo and Hausmann, countries are sorted according to the average complexity of the product they export, and products are sorted by the average fitness of the countries that export those products. So the key idea, I think, was a very important one, but their own specific measure complexity has a number of problematic aspects. And Luciano Pietronero and Andrea Zaccaria will, I'm sure, expand on this. Analytically, it gives rise to paradoxical results. And for instance, in the analysis, Qatar would be more complex than China, which is a totally incredible result. So the methodology and the specific measure complexity by Hidalgo and Hausmann has serious faults. The economic fitness and complexity approach, as this has been pioneered by Luciano Pietronero and his team in Rome. And they look at cross-country differences in production and export structures through their revealed comparative advantage. And effectively, a product is complex if low fitness countries do not export it. That's very roughly, I hope not too inaccurately, a way of describing one feature of their approach. So economic fitness in that context corresponds to the diversification weighted by the complexity of the product. And the fitness can be defined for each productive sector, and the evolution of fitness can be analyzed with methods of machine learning. And Andrea Zaccaria has developed a highly sophisticated approach to apply machine learning to the evolution of fitness. So from an economic point of view, standard economic fitness can be seen as complementary to total factor productivity. This is a way of linking the analysis of economic fitness and complexity to more traditional, more conventional analysis of growth. And also this metric developed by Luciano Pietronero and his team has been shown to be a very accurate predictor of growth and to outperform conventional predictions, for instance, developed by the IMF or other leading institutes. So their approach can be more accurate in terms of forecasting out of sample economic performance of a cross-section of countries. So I'd like to finish here my bit of the presentation and leave the floor to Luciano Pietronero.
Yes, thank you very much, Pasquale. Maybe in the meantime, I understood how to do the share screen. I try to share the screen, okay? Let's see. Okay, it should work. It works?
Yes, it does work. Thank you very much, Luciano.
My slides. Very good. Okay, so you see. Well, thank you very much, Pasquale and colleagues. I would have loved to come to London after 2 years of being blocked, but now travel is okay, but I have a little other family problems, so I couldn't come. But next time I want to come to London, where, by the way, my oldest son works, so I have many reasons. So consider me as would like to be there, okay? And thank you, Pasquale. I enjoyed your view, and I especially enjoy it because it's not really my perspective. Because, you know, I'm a physicist, so I don't know economics. So you have put our story embedded into economics, which I think is highly appreciable for all of us. But let me tell you how the story started. It started 7, 8 years ago with a little work I did with Zaccaria to improve the Hausmann-Hidalgo algorithm, and then it grew a lot. So as you see, many people are here in this list. Maybe I forgot some. Then the blue people are the people from the World Bank. The World Bank, they came to us from our papers. So we didn't have to push our story. They just came to Rome and said, we saw your paper, you solve many of the previous problems, so we want to collaborate. And this was already 4 or 5 years ago. So at the beginning, they came to us, and in particular, Masoud Kader is the person who is still pushing, developing these ideas within the World Bank. Then a recent development is the European Commission, the JRC, where 3 people from our group have been hired there to do this type of analysis. And then, as you see, there are several other people. Now we are at this Enrico Fermi. Mostly, I was for 35 years professor of physics at Sapienza. I'm in pension since 1 year. I have this marvelous job from the Italian government to be president of this Enrico Fermi place, which is the place where nuclear physics was born. Really the first fission of Uranius was done a few meters from my office. So I feel especially honored to be in this historical place, and we do our best to honor it for what we can do with respect to Enrico Fermi. The comparison is pretty tough, but at least we do our best. If you come to Rome, you should visit us. It's a beautiful building in the heart of the city with historical, in Rome there is not just the Colosseum, there is also this place where nuclear physics was invented. Okay, now what we want to do. Okay, first let me tell you what we have achieved. So you see, the first point is we want to add something to the economic analysis, which comes from the fact that we are physicists. So it should be a little bit more rigorous, you see. There's no point that we do the same. We should do something a little bit different. And so rigor, scientific rigor, is our specific element. So whatever we do, we try to check whether it's wrong, because this is important. If it is wrong, we change it. This is actually a little problem with economic ideology. People are not so willing to change wrong ideas, but we do this a lot. So we make a lot of tests. For example, we try to have experiments, as Pasquale mentioned. An important experiment for us was the back test of growth, comparing with IMF, and many other things like this. So this is our real specific element that we are proud, and we try to implement it as much as possible. So this, as you see, Bloomberg acknowledged that somehow the method works better than other methods, and this has been adopted by the World Bank more and more, and JRC, European Commission, to evaluate the project of the Recovery Fund. So if you go into the website of the EU, then you can see 27 somehow little papers, each for each country. Unfortunately, not 28 for reasons you know very well, but I mean, at least 27 are there, and they are analyzed with our method. So the idea is, after the Recovery Fund, what is the increase in complexity or in fitness that these countries will have in each specific sector. So we are especially happy that scientific methodology, which was arising from a little group of physicists in the area of complexity, is adopted by mainstream economic institutions, on a purely scientific basis. So this is also a very good example of interdisciplinary collaboration. And I tell you what is our little secret to have somehow economic institutions to listen to us. Our little secret is, on one hand, we pretend to have a little bit of superiority in the science. So we have 50% arrogance, typical of the physicist. But this is not the original part. The original part is the second 50%, which is humility, because we accept your evaluation of what we do. We accept that economists tell us whether our results are good or bad, and we accept their advices. So this dual thing of a little bit of arrogance, a little bit of humility, has been a good strategy to enter this mainstream economic institution and to be accepted as interesting partners to discuss. Okay, now what we want to do? I like to present things with the sharp question, So if you have a sharp question, then you can say, yes, I have understood it, or no, I don't understand. The question is growth. This is a little picture, of Shanghai. If you make the same picture for Brazil or for Russia, from 1990 to 2010, not much has happened. Instead, China had a fantastic growth. So the fantastic growth of China is, for us, one of the targets that we want to try to understand. Why we want to understand it? Because, since you are interested in Africa, I made a little comment about Africa, and I come back. So a few years ago, Joe Stiglitz was so kind to invite me to this task force on industrialization of Africa in Jordan in 2014. There was this beautiful booklet of 221 pages edited by Yao Ansu. And what you find, and this is all the information about the African countries, according to very respectable scientists. What you find in this book? You find a page like this, a lot of data. Don't look at that, it's just to show off. So you find another page like this, and you find 200 pages like this. You see, 200 pages of data. Now, in order to draw a conclusion, you have to give a priority on this data. So if you are neoliberalist, maybe you consider one data better than another. If you are a Marxist, you consider the opposite, and so on and so forth. So the idea is, you have all the information in this book. There is no more information, but the conclusion is not obvious. It's not very scientific. It can be clever, but it's not very scientific, and it is certainly subjective, because one guy will certainly draw different conclusions with respect to another guy, just because he has a different criteria to put weights. Okay, just to show you what we want to do, we want to transform 200 pages in one page, This is our analysis of sub-Saharan Africa. These are the trajectories of the blue, the sub-Saharan countries, plotted in this plan, which is the fitness. The fitness, I mean, colloquially, is how good you are. I mean, it's the skill capability. I will define it technically. But this is how good you are on the horizontal, and on the vertical, how much money you make. Okay. Now you can see that there are also red countries. The red countries are those that already developed. Particularly interesting is Vietnam, because you see Vietnam started 20 years ago, not far from where today is Kenya, Senegal, and Uganda. And I made a little vertical dashed line to argue that that is more or less the level of fitness that you should have in order to become a sort of industrial country, at least at the beginning. So you see, we have one graph which contains everything we can do in this, I mean, for this particular question. And then this graph can be right or wrong, because if tomorrow, instead of Kenya, Senegal, and Uganda, Benin develops a lot, then we are wrong, okay, and so on. So you see, this is what we want to do. If you repeat our analysis, you will get the same graph without any opinion involved, so without any ideology. So this is our result. So how do we achieve this? Again, we go back to China. This is the fantastic GDP growth of China from 79, which, by the way, is the year I first went to China for the first time, was like going to the moon, I mean, and up to more or less today. What is incredible about this is that it is for 30 years or more, it is above 5%. Now, this is in contrast with what the common wisdom was. The common wisdom was explained to me by Larry Summers in person. We met and discussed. Larry Summers was the former Secretary of Treasury of US. And his idea was that if you look at the statistics of fast growth for many countries, for example, Brazil and many others, they have a fast growth which lasted about 8 to 10 years, not more. So it's 8 to 10 years plus or minus 2. Now look at 1990 in this graph. You see, if we are in 1990 and you argue like Larry, you may think, well, China had its fast growth for 10 years, and now it's finished, and it will go back to 2% or less. But then it goes instead exactly the other way. It goes again to 14% and so on. So this led to a very strange list of opinions. These are collected by Godfrey Roberts in his website, not by me. So they show the opinion of leading people and institutions about China. You see, in 1990, the economy started to argue that China's growth has to stop because of this argument at 8 or 10 years. And then, you know, it didn't stop. But still, people argued that now it stops. Now it stops for 30 years. Okay. I love this situation because this is a situation that there is something to understand really, not just minor details. So here we have people who have all the data. They are clever, but somehow the result is, you know, fundamentally problematic. Okay. So what's wrong? Maybe you need more data, but it's difficult to think that Nuria Rubini or The Economist or whatever, they don't have the data and I can have more. So I thought in a different way, and I started asking this question. If you have more data, are you sure you do better? It looks a silly question, but it is not. It is not, because when you have a lot of data, you have a lot of dimension of the data, and somehow you have to add education to pollution in some way to get the GDP growth. Now, education plus pollution is the same as adding apple with bananas, which we were all taught you shouldn't do. This means technically that you have to introduce parameters. So you have to say, you know, 3% more of education corresponds to 5% less of pollution with respect to GDP, something like this. So the more parameters you have, the more dimensions, the more you have to have unavoidable ambiguities or noise into the problem. So I thought, instead of going in the direction of more information, we go in the direction of less noise. This means that our big data story starts by reducing the data a lot, essentially going to zero noise and go to one single data. So that's what we do. That's the intellectual thing. For those who are mathematically oriented, this is a translation into economics of the Poincaré, the famous French mathematician, problem of dynamical system forecasting. That says if you have a high dimension, it's a big problem. Okay, that's a similar story. Okay, so we want to reduce the noise. And then we start taking a single piece of data. Which is the best single piece of data that tells you how good you are in the sense of industry capabilities and all the like? Well, it could be the labor that you have in your country. You have the type of jobs. Indeed, this would be very nice. Unfortunately, in the world, this is not homogeneous. So people don't name the jobs with the same names. And this is a problem because we need the homogeneous definition. So the second best is the products that you make. And this we check with the export. So we don't do an export analysis in the traditional sense, but the export is a proximity to understand what are your competitive products. Okay, so this is the intellectual framework. Then we can do the economic fitness, but we don't throw away the other data. With the other data, you can have data on patents, then you do the technological fitness, on science, and you do the scientific fitness, and so on. Then we will have 3 platforms, each of which has 0 parameters, okay? And so we start with the economic fitness. The idea is to complement the money you make with the concept how good you are, okay? And how good you are, we want to learn from the products. Look at the products. Here is a chart. On the vertical axis is the high level. This is already applying the method. So on top we have the top countries, and on the right we have the more technological products. Now you see, if you look at the top, you see that the very top country does highly technological stuff, but also medium and low level. So it's totally diversified. This is against the argument of Ricardo. David Ricardo, not Ricardo Hausmann, but we will say something against the other Ricardo as well in a few minutes. So we are against all the Ricardos. Okay, Ricardo argued you should specialize, and that's not what happens. Okay, so we learn that this is not what happens. And what happens is something very interesting, because you see, you have a triangular matrix which resembles ecological system, biological systems, and so on, which makes a sort of philosophical, leads to a philosophical argument that somehow economics is a branch of biology. There are these animals, that try to do something optimal for us. Okay, why not? So in any case, we learned that diversification is a fundamental element. And this thing is called nestedness, and there is a lot of literature in ecology about nestedness. I didn't know it, I learned after. But in any case, now we see the data, what the data tell us, diversification is important, and we want to do what is written here in the bottom, going from qualitative to quantitative, so invent some algorithm. How do we invent the algorithm? Okay, I make it very simple. MCP is the matrix you have just seen. And let's make it 1 or 0. So MCP means that it is 1 if the country C produces the product P. It is 0 if it doesn't, with a certain threshold. So we say the fitness is the diversification, so the sum over the products of MCP. How many products do you make? But then, and this we learn from the data. But we also can think with our own head in addition to looking at the data. So clearly, if your product is this little bottle of water, it is not the same that if you produce the iPhone. Okay, so we want to weight this diversification with the complexity of the products. And then, so this means that the diversification is the resilience of the system, and the complexity is the wealth, the gain that you make, because if your product is complex, you earn more money from it. So the fitness is diversification weighted by complexity. What about the relation between complexity and the fitness? Okay, this is where we totally depart from what Hidalgo Hausmann attempted. for reason I tell you in a minute, but let's see how we made the argument. So if everybody is able to build a little bottle of water, this is certainly of low value. So we write 1 divided everybody who can produce the bottle of water, because the more can produce the bottle of water, the less it has complexity. But there is a but. If this bottle of water is produced by Germany, which is the country that makes essentially all products, or US or China, well, this is zero information, because, I mean, this country makes everything, so it's no information. If this bottle of water is produced by Niger, for example, which is a country with low fitness, then this is a very important information, because it means this sets a limit on the complexity of this. So we weight the denominator with the inverse of the fitness. So the denominator has more weight if your fitness is low. In words, this means that the complexity is high if only few high fitness country can produce this product. As soon as one low fitness country produces that product, the complexity drops down. So as you see, it makes a lot of sense, and it was one of our little invention, also the diversification on the left part. Okay, so this is how the thing was invented. And this is what it means. I mean, my words were supposed to be backed by this graph here. Okay, so diversification weighted by complexity, and then the nonlinear relation between fitness and quality. What did Hausmann Hidalgo do? They wrote a paper in 2009, which has a method called the method of reflection. I think this method made a hell of a lot of confusion even to them, because, for example, they talk about diversification in the introduction of the paper, but they don't realize that their algorithm has essentially zero diversification. You can do this if you rewrite Hausmann Hidalgo in our words, which can be done, and it is very simple. The fitness of a country corresponds to the average complexity of the products you make, and the complexity of a product is the average fitness of the country that make. So if somebody would tell me this, I mean, having coffee, I say, well, it sounds reasonable. But then after the coffee, I say, well, not really. Why? First question, you see, the first question eliminates completely the diversification. So if you have a country that produces all the products in the world, 1,000 products, and then you have another country that produces only one product, a little bit higher in complexity than the average of all the products in the world, the second country is better than the first, which is totally nonsense, okay? But even the second equation is problematic, because if you consider, for example, the complexity of oil, just the simple oil that you get from the ground, no technology, okay, in this fitness that the country produce oil, there is also US, UK, and Norway. So there are countries that produce oil by chance, they are high level by chance, but not because they produce oil. You see, so you get an artificial push-up of certain commodities for totally spurious reasons. So you see, the two equations are problematic. This is the basis of the problems that was mentioned by Pasquale, that, Qatar becomes higher than China in complexity. I don't go into more detail. I could show you more detail, but okay. If you are curious, there are many papers, or you can write to me, you are welcome. So what do we learn? Many people ask me the following, okay, professor, for example, when I went to Goldman Sachs, they say, well, how do we know that our experts don't reach the same results that you reach by their methods? Okay, in order to answer this question, just to Goldman Sachs, I prepared this slide. You see, you remember the brick story, 2001 by the president of Goldman Sachs. The argument is, if you look at total GDP, you get the picture on the left, which looks, these countries are similar. I mean, high GDP, and going up somewhat. So you can make the argument that they dominate the world economy. But if you look at the fitness, the story is totally different. For example, China is going very well, even better than the total GDP. India is pretty high and keeping a high level. But Brazil and Russia are terrible, and their fitness is decreasing. So this means that these four countries not only are totally different in our view, in the fitness view, but their trends are totally different. By the way, the war, Russia-Ukraine, in my opinion, has to do with these drops. Okay, just if we can talk more about this, because you see, these are countries that are not going into an evolution of natural, you know, how to say, I mean, of a healthy economy made on products, on complexity, and so on. They're just selling their raw material mostly, or at least too much with respect to the size. Okay, so you see, this is meant to show that we get different information which is not contained in the standard analysis. Then this is our basic chart, fitness, GDP, so how good you are and how much money you make. And I draw this red line to argue that if you are there, more or less, you are in equilibrium. You make as much money as you should with respect to your industrial economic capabilities. Then you see there are some strong outliers. For example, on the left, upper left, you see the oil producer, Bahrain, Saudi Arabia, Oman. They are definitely above in terms of money because they have oil. So then you see Iceland even above them. Iceland in this year, this is 95, they were gambling with financial derivatives and they went bankrupt. So you see, if you are there, it's either you have oil or you are at risk. Let's look at the other side. You see, the big outlier on the other side is China. China in 95, it had a huge value of fitness, almost as much as the Western economies, but with a very low GDP per capita. So in our analysis, this is a situation of great potential for development. And in fact, if we follow the following 15 years, you get all this little spaghetti, but look at China. China went up like hell. Consider that now China total production is of the order of US, so it's a big change into the world economy, and it contains a quarter of the human population. So you see, we have solved the China mystery. So why China went so well? Because it was able to increase the fitness a lot, even though they didn't know they were using the fitness, they did it by themselves, but now we can rationalize this situation a little bit better. Then the rest of the graphs are a little messy. So in order to help your eye to understand what happens, we make some sort of average. So you see, we take a certain region and we take the average wind in that region. And here it begins to appear a pattern. On the right, you have a regular pattern. On the left, you have a more chaotic pattern. If you make the boxes smaller, you see something very nice, that you have a green region where you can do forecasting on the basis of this data on this type of dynamical system represented by this picture. And then the idea is that on the right, you have high quality forecasting, and on the left, you have low quality forecasting. Now, introducing the quality of forecasting on a scientific basis is a new thing, and I think is as important as the forecasting itself. Because if I tell you, my forecasting is that you grow 5%, but I tell you, however, watch out, this is a low quality forecasting for me. Or if I tell you, you grow 5% and this is high quality forecasting, the two things are very different. Okay, now, out of this, we made a long story to do the forecasting from this perspective, and it works very well. Okay, so I don't go into details. There are several papers, but this is the basic, beautiful summary by Bloomberg View. Then, okay, this was the story of Larry Summers and China, so I make it short. So you see, he just argued that most countries grow 5%, more than 5%, only for 8 to 10 years, so China should go back to 2%. We argued, no, this is not true, because China has nothing to do with Brazil. You see here, China GDP per capita for some period was similar or below Brazil, but the fitness was already much superior. And China has still a way to go before reaching the diagonal line. Now this graph is, this picture is 2010. Now China is already halfway into the dashed line. Okay, then you see how we built the story for Africa, okay, which is where I started. Okay, so you see, that's what we do. Okay, then how to go out of the poverty trap. Also here, you see, we have an extra dimension. So it is very important to have a high fitness rather than to have a lot of money. So you see, it is more likely that a poor country with reasonably high fitness, like was Vietnam 20 years ago, can go out of the poverty trap rather than Saudi Arabia. Of course, to call poverty trap for Saudi Arabia appears ridiculous because poverty is not a word appropriate to Saudi Arabia. But here we mean poverty in the sense that you are able to make money from industry. So we should eliminate the word poverty trap, which say industrial trap, okay? So it is better to be poor but capable rather than unable but rich. This also solves many puzzles. For example, India, you know, India started growing a lot when it had a drop in GDP per capita, which appeared, you know, counterintuitive, but it had a high fitness. Then a lot of people say, okay, you say many good things about China, but look, I mean, China, after all, you know, they are just assembling stuff. They don't really produce the iPhone. They pack it in Shanghai. It is produced in California. Okay, we take the challenge. So we studied the fitness of what you export minus the fitness of what you import. So this gives us the value add of the fitness and can answer the question of what is the situation of China. So this is the value added fitness of China, Germany, Japan, and USA. You see, in 2000, China was definitely below the other three, but today it is almost on the top. So the analysis is that China started being an assembler, but since 5 or so years, it is definitely also an innovator, it's even for high tech. Okay, this is what the type of things we can do, and I mean, they seem to fit what you see in the data. Then you can do the fitness of sector. Okay, this is clear what it means, and then this gives a broader perspective than just a number. So the sectors here, I mean, if you go counterclockwise, the first half are simple products. So, for example, 113, 315, these are very simple. And then you go around the clock and you get 325, 334 that are the most sophisticated, okay? So you see, Germany is high level almost everywhere. It is leaving that away for, I mean, because it is more convenient not to do them anymore, the very, very simple products. And now, this is how to read this sector fitness chart. Now we can see, for example, China is following Germany. So China also does everything. But if you see, for example, 312, which is what? 312, I don't find, okay, whatever. So it is a product that they are leaving. But look at what happens, for example, USA. USA are leaving quite a lot of simple products, and this trend is more extreme in Japan. Japan has totally abandoned the left part of the moon because it only makes products with high tech. Now, is it good or bad for a country to do the half moon or the full moon? Okay, this is not obvious, the answer, because this can depend on geography, on demography, and on a lot of other things. But in any case, these graphs show you a very sharp situation for what is the fitness, the sector fitness of the country. And you see the differences are quite dramatic. South Korea is following somewhat Japan, leaving away the simple products. Saudi Arabia is basically not able to do much. So it would be very difficult, even though they have a lot of money. Then the product progression is what Andrea Zaccaria will talk, and I stop in a couple of minutes. I just tell you what is the problem there. Maybe he will tell you, so I don't anticipate. You can do a lot of other things. For example, you can do the same thing for technological fitness from the patents. Also here, the matrix is triangular, so we can safely apply the algorithm. And then you get like the information for the technological fitness with respect to the product fitness. So here, that is for the various regions of China. Some regions have a high technological fitness and low industrial fitness, product fitness, and others the opposite. So it means you are improving or you are going down with respect to your level of complexity. Okay, then you can do, okay, other analysis, okay. Then what about companies? I just tell you 1 minute of companies. Also, you know, this is country product, what you have seen before in other colors. What if you do with companies? If you do with companies, you see, you find this beautiful situation in which you have block nestedness. So this means each company lives in a certain ecosystem within which diversification is important. But the first thing is to identify the ecosystem. Okay, this is very new, and we are writing papers just on this now. So this means that for us, the country is like a big forest with a lot of animals and plants. So diversification, global diversification is essential. A company is like a single animal which lives in its own ecosystem. Within the ecosystem, diversification is also important. Okay, I think I stop here, just telling you the following. You see, what we have done is an example of artificial intelligence, of artisan-like. So we start focusing on the links, we eliminate a lot of data to eliminate the noise, then we invent a new algorithm, then we go to a hierarchical use of data. So this means that, you know, this data science is still a big adventure, and there is space for thinking and for inventing stuff. It is not that you have data, you have a big computer, and you just turn the crank and get the result. It is not like this. I wonder if you put all the economic data into the largest computer in the world with a very good program of neural network, I don't think it would get these results. So it is a beautiful area for creativity, and that's what we like, really. Thank you very much.
Thank you indeed. Absolutely interesting, Luciano. So we now move to the third part of the presentation by Andrea.
Okay. First of all, many thanks for your kind invitation to discuss these new developments in economic complexity. Many thanks to Pasquale and Luciano for the introduction. And here I would like to talk about the concept of relatedness, which is something that is quite popular in economic complexity, and we are trying to assess it by using machine learning. And this gives the possibility to apply this concept in a number of applications, practical and also for makers. The idea is the following. Relatedness is a concept that is connected to the general idea of distance. That is, two objects, for instance, a wheel and a car, are related if they share the capabilities that are needed in order to be able to be competitive, for instance, in exporting both products. So it is a concept related to the proximity, to the similarity of two objects. We can say that a wood chair is related to a table, and they are both far from a desktop computer, for instance. This concept can be extended, and this is the direction in which we use it most. This concept can be extended to economic actors and economic activities. So, for instance, we can say that Oman is more or less related to cars. And this means that an investment and having success in that particular activity is feasible or not. And this human activity can be also a technological activity. So, for instance, patenting in a given technological sector, and by computing this relatedness among different sectors and between countries and sectors, we can build paths of development that countries or firms explore. We have applied and we are applying these concepts to a number of in a number of different frameworks. So, for instance, this idea of feasibility, the fact that you are very close to producing a given product or to patenting in a given technological sector is connected to the idea that it is easier for you to go in that direction. And so, for instance, this could be useful to target a specific country to outsource a production, or to strategically design preferred development paths. We also study an application in merger and acquisitions, in which we study whether it's better for a given company to target a firm that is closer or in a different position with respect to the space of technologies. And this is obviously an element of the whole decision process, but I think we believe it is quite interesting to have some kind of idea from that point of view. Here we have an example that is taken from the General Research Center website, because we are working with the European Commission, and this is an example of the results. We have a target that is direction finding compasses, that is a very specific product, and we can say which are the technological sectors, that is the sectors in which there is patenting activity. We can say the technological sectors that are more related to these target products. So what we are saying that usually countries that are competitive in this particular product are also competitive in these technological sectors. This means that the two activities are related, and so we can build a recommendation out of this information. How do we compute this measure of relatedness? First step is the data that we use, that here we show in a very schematic way. That is the country product bipartite network. And you can see that there are two layers of information. That is the first upper layer, the countries, and the second, that is the products. And we draw a line if there is a real comparative advantage for that country in that peculiar product. The result is something like this. And this is something that Luciano already showed, but I would like to stress the nested property of this database that will be useful later, is the triangular structure of the data. That is something that you do have to take into account in order to better exploit and to better design your algorithms. So here we have more than 5,000 different products, so we can go really at a finer level of detail, and so discuss very specific products. This is an example of how relatedness can be computed. You start from the export network M that I've shown you. You make a projection from bipartite to monopartite. That is, you obtain this matrix B by counting the co-occurrences of that couple of products. That is, you count how many countries are exporting both, and then you have to filter this in some way. So there are two steps. The first one is contraction, and the second one is filter. We also have applied this concept of co-occurrences by introducing also the time dimension, by putting also the statistical validation of the links, and also by considering three different layers, that is science, technology, and products. In this way, we are able to detect, as I've shown you previously, the interrelations between, for instance, a given technological sector and a given product, or between two different scientific fields. This led to this kind of graph that I already shown you, and also to something like this that is very similar. Only the layout is different. This is a work that we have done jointly with the United States Office for Outer Space Affairs, the Italian Space Agency. They ask us what is the spillover of astrophysics, that is, given the fact that a country is competitive, is publishing papers in astrophysics, are there some technological outcomes? The answer is yes, and very specific technological sectors can be highlighted. As you can see here, the list: earth drilling, chemical physical processes, data processing systems, and so on and so forth. So there are a numbers of technological sectors that are activated after that, or given by the fact that that country is investing in a specific scientific fields, in this specific example, astrophysics. We also applied this concept of relatedness to physics sectors by using machine learning. Here, in particular, we have used an algorithm called word2vec that is able to extract a highly dimensional representation of words. In this case, words were extracted from articles, from scientific articles, and these words were physics sectors. By going from this higher dimensional representation to a lower dimensional one, we can draw in this plane also some trajectories that you can see, this kind of spaghetti going around, and some very reasonable patterns, at least for a physicist, emerge. That is nuclear physics and elementary particles on one side, on the right, and condensed matter on the left, and interdisciplinary physics that is spread more or less all around, but more towards the condensed matter physics. And so one can also follow the specific trajectories, but there is something that is very funny for a physicist, but I will not go here deeper in the details. The point here that I wanted to stress is that there are very different definitions of relatedness. Here there is a not comprehensive list of them, and I have shown you 3, but there are more. And so the point is that we would like to scientifically validate and to test which is the best definition of relatedness, and to check whether our definition could be possibly wrong. So we devise an experiment by comparing the time evolution of these bipartite networks. That is, we check whether a country that is not doing a given product will export that product in a competitive way after a given number of years. The hypothesis here that we are testing is that on average, we are expecting to find more activation, that is, more new products, if that product is more related, is more close to that country. So the more your relatedness measure is correct, the more you will be able to predict that the new products that are highly related according to that measure will enter in the export basket of a country. And this is how we built the machine learning procedure. I will not go in the details here, but the idea is that here you have an export basket of 4-5K products, and given the fact that you are able now to export a given number and those peculiar products, we are able to assess the probability that you will be, after a given amount of years, that is usually 5 years, that you are non-competitive or competitive in a product in which you are now not competitive. And here I show 3 performance indicators that are usually adopted in machine learning, but in any case, they are quite coherent one with the other. And the co-occurrence based networks, such as the product space, are here in green. And you can see that the best performance are from tree-based machine learning. So here, for instance, we have an algorithm that is called the boosted trees, that is a variation of decision trees. We want to also recover the interpretability of the machine learning approach by keeping the predictive power intact. And in order to do this, we made a low dimensionality representation of the scores that leads to this that we call the continuous projection space, in which here each dot is a product, and reasonable patterns of sectors appear. And here, for instance, what we always notice is that textile is always quite isolated, also fish. And here, given this continuous space of products, we can study how country diffuse, how country explore or exploit this space. And so here, for instance, you can see the time evolution of Ethiopia, China, and Vietnam as they diffuse and move in this space of products. We can do the same also with the technological codes that I mentioned earlier. So here we are talking about patenting activity. And also here we have shown that machine learning based approach to relatedness is able to better predict which will be the next patenting activity of firms. And also the this important database that we have recently obtained from the Italian Statistical Agency is very useful for us, because it is the bipartite company product data. And from this figure here, you can see that when we apply our tree-based machine learning models, in this case random forest, on firms, they are able to predict much better with respect to network-based techniques, especially the ones that are based on country-level analysis. We always like to try to understand why something is working better, and here is where it comes the different structure of the data. Here on the right, you can see the nestedness of the country product data. The fact that high diversification countries are doing more or less all the products has important consequences, because you are counting as co-occurrent products that are not related. On the contrary, when you analyze the company product database, you show this in-block nested pattern. That is, you have nested, but inside the blocks. So it is more important to find what is the right block for the specific company and to compute the relatedness, because there is the ecosystem that Luciano was talking about. And so there are a number of problems that are coming from the use of co-occurrences at country level that are solved by the use of machine learning and company level data. But the important thing is this one is that you are really able to predict what is the next product of a given firm. I close my talk with a specific example that is being made by Giambattista Albora, that is about the application of random forest prediction in for the forecast of Egypt exports. And for instance, this is the distribution of the random forest scores for different products of Egypt. So here, Egypt is related to many products. No, if you take this product here, that is plastics, tubes of polymer, and vinyl chloride, that is, you see, a very specific product. If you see this product, this is the most related to what Egypt is already doing. This plot is used by computing everything in 2002. Look what happens next. In 2002, the Egypt had not revealed comparative advantage in that very specific product, but in the following years, things go better and better, and then it started to export it in a competitive way. This is a specific example, but going back, we are able, on average, to give a statistically well-defined and robust goodness of predictions. So these are my take-home messages. We are using relatedness as a measure of the feasibility of a new product or technology for a specific economic actor that can be a country or a firm. We test them because we want to prove ourselves wrong, if it is possible. This has a number of subtle things one should consider, but I do not enter in this detail. And we have found that machine learning outperforms network-based approached. And the firm level data also provide a very good assessment of relatedness. Here, I leave you with some preprints if you want to go a little deeper, or I am very open to questions. They are very welcome. And in the meanwhile, I thank you for your attention.
So please join me in giving a hand of applause to Pasquale, to Luciano, and to Andrea. A very, super interesting presentation that cut across the areas of fitness, complexity, and relatedness in terms of feasibility of a new product and the use of machine learning. And a number of common themes, but all the three areas are heavily interrelated. And also what is interesting is that basically it's building on the traditional yardstick that has been with us for so many years, the measure of GDP. The elementary first year concept of GDP in most foundation courses is that the GDP can be computed using the product method, or using the income method, or using the expenditure method. In this case, the focus area in all these areas in the product is in the nature of the product. So there you're looking at fitness or complexity or in terms of relatedness. But also interesting the fact that this is applied to countries as you at the macro level, the big aggregate level, also to firms or companies at the micro level. Absolutely interesting. Maybe we should take a couple of questions, comments, observations from the audience. Please, please indicate by show of putting up your hand, and I think I am monitoring to see. I think there is a hand up. Yes, Doug, please go ahead.
Well, good afternoon, and thank you, Victor, and thank you for the presenters for a really excellent presentation and really fascinating and really interesting work. So, I mean, a couple of things to say and sort of a question as well. So, I think one is that it's really useful to have all these different measures and not just to rely on GDP its own or income. And I think that's what we. And also, you put up at some point the ACET report, Afghan Centre for Economic Transformation report on sort of growth at depth, and we've done something sort of similar over time to think about economic transformation, and that came from the idea that, particularly in the poorer countries, that the growth wasn't a problem necessarily, because there was quite a bit of growth in low-income countries for quite some time. But it was the pattern of growth that wasn't really helpful. It wasn't really transformation to productivity change, to fitness, to complexity, and all this. And I think so this adds to that literature, which I think is really really helpful. Now you then have a range of measures, and I think that's really good and really useful. To sort of, and my feeling is that you have those because you can then target. So you know one firm or you need another, you know one product or another, you know one sector or another. You can actually think about your economic strategy when you think about development policy in a country, at the country level or a sector level. You can sort of say, well, let's focus, let's target, rather than saying let's just provide an investment climate for all activities to prosper. You actually say, well, actually there's a best bet. This particular product or this particular country or this particular combination is more promising for the future. So you want to target. Now, when we went into countries to sort of think a bit about that, we tried to use different techniques, and with the Hausman technique as well, the product space. We had Maggie McMillan and Daniel Roderick about productivity change between and within sectors, firm level surveys and so on. And what we then try to do is to bring them together, and rather than saying, well, this technique is better than the other, wouldn't it be useful to sort of try and sort of bring all the techniques together and then actually say, well, if we are thinking that all the techniques come to the same conclusion, then we have got a reasonable basis on which to sort of base our policy. If they're wildly different, then we need to understand, and then there may be different reasons. So I suppose the question is sort of, can you sort of look backwards or so 20 years ago and say and sort of think about the different techniques that exist, and then your technique and apply to a particular country, and then see which has performed really well and why, and sort of where are the comparisons, so that basically that you can provide a tool that can be useful for international organizations like the World Bank, as you mentioned, but also others, and also the support has been provided to governments that are seeking to develop a country to sort of say, well, actually, if you bring these together and you do these techniques, and your technique is one of the instruments that you can use, then you will have a good basis for economic policy going forward.
Maybe can you hear me?
Yeah, yes, we can hear you, Luciano. Please go ahead.
For me, can I put back my slides because that will make the answer faster?
Yes, if you wish. Yeah, go ahead.
Okay. Yes, because you see, I skipped a few things, but maybe now is the time to go back to them. Okay, just a moment. I put it back. So, okay, open share. Okay, here we are. You see it? You can see it?
Yes, it's coming. Yes, we can see it. Thank you.
Now, so the question is, if we have many techniques and they all agree, this reinforces the argument. I mean, this is true and not true. I mean, it depends. So if you have different techniques which give you a reasonable answer in different perspectives, then I would agree with you. But you see, if one technique says that 2 + 2 is 4, and the other technique says that 2 + 2 is 8, and then you say, well, let's decide that 2 + 2 is 6, I disagree. It's clear what I mean? Okay. Why I make this specific statement? Because if you use Hausmann, you end up with this type of pathologies. Okay. For example, this is a screenshot from their website a couple of years ago. Saudi Arabia has ECI, the Economic Complexity Index, is the analogous of our fitness, above China. Now, this is simply nonsense. It's not a different point of view, but it's a nonsense. I mean, for example, here the sector fitness of China below, which produces almost everything. On the right, you have the sector fitness of Saudi Arabia, which produces essentially nothing. So how is it possible that their complexity index puts Saudi Arabia above? Well, I explained it to you. You see, okay, no, I don't have it here. No, but let me put it in another way. The fact that, you see, it comes, I don't have the slide here, I tell you in words. So you remember the second equation tells you that the fitness, or ECI, is the average of the complexity of a product is the average of the fitness of the countries that take oil, which is what Saudi Arabia does. Oil acquires, in this definition, the fitness of USA, UK, and the like. So it is pushed up. Okay, then you disregard the diversification by taking only the average. So with the second equation, you push the oil up. With the first equation, you eliminate the diversification. And here you get the absurd result that the industrial complexity of Saudi Arabia is above China. Now, I think this is simply wrong. It's not a matter of opinions, okay? The fact that this is simply wrong, you can see with another paradox I have worked out to clarify this. You know, this fact that diversification is absent from the Hausmann method has this paradoxical conclusion. Take China. For us, China is first or second, I mean, among the top 3. Suppose that you go to China and you say, now you close all your factories and you only stay with the industry of the coal fish, okay? That's the only industry China is. The rest you burn. Okay, for us, it goes from first or top 3 to last, to 169. For them, it goes from 40th to 4. So you increase the economic fitness or the ECI of China if you destroy everything but the coal fish. So in my opinion, this is not a concept that you want to average with anything. This is a concept like 2 + 2 = 8. It's just wrong. Okay, now this is for the Hausmann. For other cases, of course, we already do within ourselves to argue that you want to evaluate, for example, Singapore. Singapore is small but highly tech, and so on. So it is clear that we don't have one number which is the holy truth for economics. I mean, in my opinion, the economic fitness is is a picture, impressionistic picture. So it gives you the correct picture of the economy in the world, but not with all the details. If you want to know the details between Italy and France, for example, which are similar, then you have to go to the technological fitness, you have to go to the research, to the science fitness, and so on and so forth. So it is clear that it's not one number. And then I agree with you that many numbers somehow can be more useful than one, but not if this number is clearly wrong as the Hausmann ECI. Okay, so 50-50. Okay, I close it.
Thank you both, Dak and Luciano. I think the point by Dak is that once we have, different variations, we can address different, issues that together make up the ecosystem. And I think also the explanation was, that here is a new method that can bring up a greater insight on fitness. So thank you both. We have 2 questions, and please, in the interest of time, if you could just go straight to the point. We have first Christine and then Bob. Christine first.
Yeah, thank you, Victor. And well, thank you, Pasquale, Luciano, and Andrea for such a great paper, and congratulations to you for this whole body of work. I mean, it really is a step forward. I've been studying competitiveness for decades now, and using GDP per capita to measure competitiveness isn't very satisfactory because you don't really know what's caused it. And I guess you've taken a step back from that, and it's really impressive what you've done. But I just wonder whether it's possible to go back a step further. I suppose my curiosity is what is it that's generating these particular export patterns that are giving you this greater ability to predict GDP per capita? You've hinted at some things. I think probably what is underlying it, my intuition, without, that's why I put this to you and you can tell me what you think of it, is that a lot of it is to do with innovation. The failure of growth theory really was a failure of neoclassical growth theory was a failure to predict growth on the basis of capital and labour inputs, because what they missed out was innovation and technology and the ability to diffuse that very quickly in an economy. And so I wonder, how far can you unravel this to get to the real cause at the bottom of it? Because targeting industries is one thing. I can see that you can use that in a policy way. And of course, that as a policy tool might be very useful. It has been much criticised in terms of picking winners, although I buy into that criticism. I think it was misrepresented really in that whole debate. But can you go back to looking at the underlying conditions that create these patterns of exports and these patterns of fitness? Can you unravel it further back? So that's my main question, really, in the interest of time. But I've got many more, but I'll leave them.
Maybe I answered to these general things. I answered then for specific machine learning. If you pronounce machine learning, then it goes to Andrea. Okay. Well, your question is very interesting and very broad. You say, what is the holy grail secret of all this stuff, right? Well, I mean, there are many answers. I try to give you a short view of the way I think. I mean, what do we want to know? For example, suppose you know a guy who builds furniture, okay? Then you go to his shop and you check what he does. That's what we do with looking at the export. Then you go and you look at his bank account, okay? Now, if he produces very beautiful furniture and his bank account is small, you would say, well, guy, you may go well, you buy stocks, okay? That's the idea, I mean, qualitatively. So we want to know the level of, somehow the fitness is the indicator of the economy of knowledge, okay? So oil doesn't matter, money doesn't matter, it matters what you are able to do, okay? And for this, not necessarily export is the only thing, because if you give me if you give us the information on labor, which labor, for example, that would solve one of our weak points. Weak point for us is services. We have a little bit of services from World Bank, but you don't export services much. It's more immaterial, the service. So it's not something that goes through the customs. So our data are weak in services, okay? We try to cure it, but this is a weak point. If you give me the labor jobs, the jobs, then I have no problem with services, because I know so many people work in insurance, for example, or in local transportation, which is a service, that you don't export. So so the driving aim is to understand how clever you are, so to say, in building complex products, okay? And then we define what is the complexity and what is the being clever. And then the export is the second best option we have. The first, it would be, in my opinion, jobs, okay? It's mixed. In some cases, export can be better, but in any case, I would love to have jobs because they would solve a service problem. And then we have jobs for US, for example, for some specific countries, but they're not homogeneous, and we need the homogeneity all over the world. This is the technical problem. So whenever I talk to a World Bank, European Commission, I urge, please make an effort to have homogeneous job description, because that will be very important. So you see, not that the export is the only secret of that. Also, countries that produce a lot for internal markets, like now China, the export may be limited, you see, and still they produce a lot. So if you have the jobs, this would be better. So we don't have, I would say, an obsession for export. Export is, in our opinion, a reasonable way to guess what you are able to do and to be competitive on the market. This is true, but the idea is to understand how clever you are as a producer of products or services. We are weak on services. This we never said. I have to declare that is not our strong point. Okay. I don't know whether this was a satisfactory answer.
I would like to add a short comment.
Could I interview? Could we, thanks, Luciano, could we take Bob and then we can come back to you, Andrea? Then we can round up in the interest of time, because we have only 9 minutes time, and we might miss Bob's comments if we, please go ahead, Bob, and then we shall come to the speakers.
Thank you, everyone. It was fascinating. As a former banker, the amount of presentations with vast amounts of data that was full of noise and very little clarity. You brought a lot of clarity. I just wanted to ask, should we think of fitness as a sort of surrogate for risk? In other words, if we were to use your models for risk mitigation or risk profiling, not just growth, but are you seeing in those same trends and the utility for those trying to assess risk? Because you've got those who look at growth only, and suppose you were the rating agencies looking at countries too. The lack of diversification or scale or growth. How would you say these tools could also be very helpful as a risk management tool?
Well, it certainly is. At the beginning of my talk, I mentioned Iceland, that was an absolute outlier. So if I was a risk agency or a risk analysis group, I would say, don't put your money on Iceland. So if you are on the right side, the upper left side of the graph, then that is a risky situation, unless you have oil or any special tool. Another way to look at risk, which is appreciated by policymakers around here, that I talk often, is to define the fitness as diversification, which is a sort of risk mitigation element, weighted by the complexity, which is instead of a success in economic terms. So in a way, for example, our story that China was very good, was healthy in the economic development, because China doesn't have much raw materials after all. So they did all by real manufacturing industry. Then our story was that also countries with high fitness are also resilient. and this we made the paper with the Mexican economist that probably we never published, but in any case there is some work going on, and there was a correlation between somehow what is called resilience and fitness, which is natural because you like diversification, and you have, for example, if you look at the trajectory of Russia, now that there is so much important these days, you see that Russia went back in fitness in the recent 20 years, and it went up and down in GDP per capita because it's subject to the volatility of oil price. You see, so that is a very unhealthy economic situation. And what happened was that Russia has some very high quality technology, rockets, airplanes, and so on, bombs. But they were, contrary to US and China, they were not able to transmit this technology into a real economic industry. Okay, this would be the suggestion we would give to Russia to diversify and to make a transfer of that technology, not just to the weapons, but also to the production. But this did not happen, I mean, in our analysis. By the way, once I was, let me, a little anecdote. Once I gave a talk, I mean, either London or San Francisco, I don't remember. After my talk, I said these things about Russia. This was 5 years ago. And two guys came to me, middle-aged, 35, 40. They say, we are working for Kremlin. Would you like to become consultant of Kremlin? And then I thought, I was dreaming that I would be in the Kremlin, because your data is very important for our minister, a minister of economics. He would like your data, etc., etc. So it was my dream that I would be the great guy in the Kremlin. And they continue. It doesn't end well. They continue like this. Because your data are very important for our minister to fight against Putin. Putin was against this. Yes. So I said, okay.
Thanks, Luciano. Andrea, can we bring you back?
Okay. Sorry for the joke. It's true, by the way.
Okay, many thanks, many thanks. Just a couple of comments for the previous questions. Well, the reason why we are able to compare product space and random forest, our machine learning approaches, is because they are really trying to measure the same thing, that is relatedness, that is how much country is close to a given product that is not actually exported by that country now. So since they provide the answer of the same question, and that answer is a number, then we can compare them. And this is the reason why we make this exercise of out-of-sample forecast, just to compare these two measurement of the same thing that is relatedness. About the picking winners issue, we are not really suggesting the most feasible product as a recommendation, because this is really entering in a more complex decision process. And what is usually done then in practice by the FCC and the World Bank is providing a set of options in which the government may decide on the basis of many different measures. Our measures is, however, important because it is how close that country is to that product, how feasible is that product. But that product could be a cul-de-sac, a bottleneck, or something that on a longer term may be not very good choice. So we are providing this feasibility number, but then it is choice of the government whether to go or not in that direction. The only thing that we say is that direction is easier, but then there are other more complex measures that can be used to assess whether that choice is useful or not on a short or long term.
Thank you very much for Andrea for those closing remarks. Very helpful, and the area innovation you shared of extending the decision tree analysis version of machine learning, that's helpful in tying down some of the results you get that rank machine learning method superior to a classical forecasting techniques. In general, let me have the pleasure of thanking Pasquale, Luciano, and Andrea for exciting discussion, for whetting our appetite in these areas and different ways of looking at really what is driving performance of economies and economic systems, economic fitness, complexity, relatedness. And yes, we have now new versions, and indeed, also you provided a lot of literature that we can look at to be able to pursue these ideas further. And let me assure you, Luciano, that you are welcome to SOAS University of London, the Center for Global Finance, if you want to stay a little bit of time and work with us. Absolutely delighted. Please get ready, and we welcome you when you are ready. And for you, all participants, let me thank you indeed, great, for making the time to be with us. We are now running out of time, but we thank you so much for being with us. Now, this is the last seminar, Centro for Global Finance seminar this term, as we are closing the term, and we will be back next time with some new seminars. So thank you very much. Have a nice Easter break, and yes, we look forward to seeing you once again. Thank you.
Thank you, Victor.
Thank you very much, Victor. Thank you.
Many thanks. Many thanks.
Thank you.
Thank you.